The name of the project is Sound Operated Stopwatch. It was built on the Cypress PSoC 1 embedded system kit. Along with that, there was a microphone circuitry which was attached here, and the circuitry was made of resistors, a capacitor, and the microphone. You can use any kind of microphone circuitry available over the internet. Any simple circuitry should work for this project. So the programming side of the project was built on a state diagram, on a state flow diagram. The five main states of the diagram were an accuracy state, a button state, a microphone sensitivity state, a sound mode timer state, and the memory state. So the accuracy state can give you an accuracy up to 1 second, one half of a second, and 1/10 of a second. In the button state, the timer can be turned off using a button and also turned off using a button. In the microphone sensitivity state, you can save an average value of the surrounding noise, the average amplitude value of the surrounding sound or noise, and save that in the memory. This value can be used in the sound mode timer state, in which a value of whistle or a high pitched noise of more than double the value of the threshold or the microphone sensitivity which was saved earlier needs to turn on the timer and to turn off the timer. And lastly, in the memory state, you can either see the maximum, the minimum, and the average value of the times that were saved, either using a button state or using a sound mode timer state. As the video proceeds, I will explain you more about the state diagram, the state machine, and the whole project. So, as you saw in that short clip, there are different main states available for the user to run, and you will see the main states over here. So this should go from 1 to 5, and you will see the sub states over here. So this is the threshold mode. If you turn the threshold mode on, you would have to it would record an average value of the surrounding noise and would save it in the memory to be used in the sound mode timer state. And this is the button mode. In the button mode, the user can turn the timer on using a button and turn the timer off using the same button. And there's also another substate for that button state which would save the value in the memory. And this is the sound mode. So the values will be saved now using a high pitched whistle, which should be double the value of the microphone sensitivity state that was saved. If you don't save a value in that state, there is no problem. You can save you can initialize the value with a certain average amount that you can think is appropriate. So as you saw there, the sound mode timer state can be turned on using a whistle and can be turned off using a whistle. There was also another feature added in this state that if the timer was turned on using a whistle, the timer can be turned off using a button. So this was an added feature for sound mode timer state. And this is the memory state. As I said before, you can see the maximum value, the minimum value, and the average value. The memory state would show the maximum, minimum, and average values of all the total combined time values saved from the button state and the sound mode timer state. The whole project was built in x86 assembly language, which can be programmed on a PSoC designer IDE available on on the Cypress website. The the Cypress development kit, was programmed using a PSoC programmer, which can be connected in the laptop using a USB. There is no already defined compiler for the PSoC designer available in the system or in the IDE. You always have to program the IDE, and then you have to again program the PSoC kit so that your program should run properly. The implementation was done in x86 assembly, and it can be seen on my GitHub page. under the link of sound operated stopwatch. Thank you.